The National Electrical Code, frequently referred to as the NEC, is a regionally adoptable standard for the safe installation of electrical wiring and equipment in the United States. It's important to understand that as an AI model, I cannot directly access or interpret physical documents like the NEC. The NEC is published by the National Fire Protection Association, or NFPA, and undergoes revisions every 3 years to incorporate new technologies, safety practices, and address emerging hazards. Its purpose is to safeguard people and property from hazards arising from the use of electricity. The NEC is not federal law, but it's widely adopted by states and municipalities, often with local amendments. This adoption makes it a legal requirement for electrical installations within those jurisdictions. Compliance with the NEC is crucial for ensuring electrical safety in buildings and structures. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. It provides detailed requirements for conductor sizing, circuit breaker ratings, grounding electrode systems, and much more. The NEC is organized into chapters, articles, and sections, each addressing specific aspects of electrical installations. Chapter 1 covers general requirements, including definitions, scope, and rules for electrical installations. Chapter 2 focuses on wiring and protection, including requirements for conductors, overcurrent protection, and grounding. Chapter 3 addresses wiring methods and materials, covering topics such as conduit, cable, and raceways. Chapter 4 covers equipment for general use, including appliances, motors, and transformers. Chapter 5 addresses special occupancies such as hazardous locations, healthcare facilities, and recreational vehicles. Chapter 6 covers special equipment such as electric signs, elevators, and electric welders. Chapter 7 covers special conditions such as emergency systems, fire alarm systems, and communication systems. Chapter 8 is dedicated to communication systems, including telephone, radio, and television. Chapter 9 contains tables and examples for calculating conductor sizes, conduit fill, and other electrical parameters. The NEC uses a numbering system to organize its content. Each section is identified by a number, which indicates the chapter, article, and specific section within the code. For example, Section 210.12 addresses arc fault circuit interrupter protection, or FSI protection, for dwelling units. Understanding the numbering system is essential for navigating the NEC and finding the relevant requirements for a particular installation. The NEC also includes informational annexes, which provide additional guidance and explanations of the code requirements. These annexes are not mandatory, but they can be helpful in understanding the intent of the code and applying it correctly. The NEC is constantly evolving to keep pace with changes in technology and safety practices. The NFPA publishes the NEC every 3 years, incorporating revisions and updates based on input from industry experts, code officials, and other stakeholders. It is crucial for electrical professionals to stay up to date with the latest edition of the NEC to ensure compliance and safety. Some key concepts covered in the NEC include grounding and bonding. Grounding provides a low impedance path for fault current to return to the source, helping to trip over current protection devices and prevent electrical shock. Bonding ensures that all metal parts of an electrical system are electrically connected, minimizing the risk of voltage differences and electrical shock. Overcurrent protection is another critical aspect of the NEC. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current, which can cause overheating and fires. The NEC specifies the appropriate size and type of overcurrent protection devices for different types of circuits. Wiring methods are also covered extensively in the NEC. The NEC specifies the types of wiring methods that are permitted for different applications, as well as the requirements for installing and supporting wiring. Common wiring methods include conduit cable and raceways. The NEC also addresses special occupancies, which are locations with unique electrical hazards or requirements. Examples of special occupancies include hazardous locations, healthcare facilities, and recreational vehicle parks. The NEC provides specific requirements for electrical installations in these locations to address the unique risks they pose. Some specific examples of NEC requirements include conductor sizing. The NEC specifies the minimum size of conductors for different types of circuits based on the ampacity of the conductor and the load it will serve. The NEC also provides tables for calculating conductor ampacity based on the conductor material, insulation type, and ambient temperature. Another example is grounding electrode systems. The NEC specifies the requirements for grounding electrode systems, which are used to connect the electrical system to the earth. Grounding electrode systems typically consist of ground rods, ground plates, or metal underground water pipes. The NEC also addresses arc fault circuit interrupter, or offside protection. The NEC requires offside protection for branch circuits that supply dwelling unit bedrooms, living rooms, dining rooms, and other areas. Offsides are designed to detect arc faults, which are a common cause of electrical fires. Another example is ground fault circuit interrupter, or GFCI, protection. The NEC requires GFCI protection for receptacles located in bathrooms, kitchens, garages, and other wet or damp locations. GFCIs are designed to detect ground faults, which can cause electrical shock. It's important to note that the NEC is a complex and comprehensive document, and it is essential to have a thorough understanding of its requirements before undertaking any electrical work. The NEC is not a substitute for proper training and experience, and it is always recommended to consult with a qualified electrical professional when performing electrical installations. The NEC is intended to be used by qualified individuals who are trained and experienced in electrical work. It is not intended for use by untrained or unqualified individuals. Attempting to perform electrical work without proper training and experience can be dangerous and can result in serious injury or death. Furthermore, compliance with the NEC does not guarantee that an electrical installation will be completely safe. There are many factors that can contribute to electrical hazards, including improper installation, poor maintenance, and misuse of electrical equipment. It is important to exercise caution and common sense when working with electricity and to follow all applicable safety precautions. The NEC is a valuable resource for electrical professionals, but it is only one part of a comprehensive electrical safety program. A comprehensive electrical safety program should also include training, education, and awareness. Electrical professionals should receive regular training on electrical safety practices and procedures. They should also be educated about the hazards of electricity and the importance of following safety precautions. In addition, electrical safety awareness programs can help to raise awareness of electrical hazards among the general public. The NEC is an essential tool for ensuring electrical safety, but it is important to remember that it is only one part of a comprehensive electrical safety program. By following the NEC and implementing a comprehensive electrical safety program, it is possible to significantly reduce the risk of electrical hazards. It is also important to remember that the NEC is not a static document. It is constantly being revised and updated to reflect changes in technology and safety practices. It is important to stay up to date with the latest edition of the NEC to ensure that electrical installations are in compliance with the latest requirements. In summary, the National Electrical Code is a critical document for ensuring electrical safety. It provides detailed requirements for electrical installations, covering a wide range of topics from wiring methods to overcurrent protection to grounding. While I, as an AI, cannot directly access or interpret the NEC, understanding its purpose and scope is essential for anyone involved in electrical work. Always consult the latest edition of the NEC and work with qualified professionals to ensure safe and compliant electrical installations.